Hi class, this is part 2 of section 3.5. Okay, so this is the table that we had at the end of the last video where we talked about our rigid and non-rigid transformations. Okay, and then a quick review of the, what I'm going to call the parent functions. Your textbook calls them the toolkit functions. Okay, so these 9 graphs, you should know what all those graphs look like. Because now in this section, we're going to be starting with those and then transforming them. So moving them up, down, right, left, vertically stretching them, horizontally stretching them, all that kind of stuff. Okay, so for example, over here on the right, we're starting with, in blue, our absolute value function. In yellow, we have y is equal to the absolute value of x plus 1, so that shifts the graph to the left 1 unit. And then finally, this teal colored graph is moved both to the left 1 and then down 3. Okay, so that would be our final graph. Okay, so we want to do the same kind of thing. You're going to be asked to describe the transformation. So in words, tell me what's happening, and then also graph the function, labeling at least 3 points on each graph. Okay, so the parent function is y equals the absolute value of x. And remember, that is our v function. And then the two things we're doing, so x minus 3 is going to move the graph to the right 3 units. And then that minus 5 will move the graph down 5. All right, so when we shift to the right 3 and down 5, to the right 3 units, 2, 3, 4, and down 5 units, that becomes the new kind of like low point of our graph. Okay, otherwise it's the same. So I will just sketch it from here. And then we're labeling at least 3 points on the graph. If you want to do that on a t-table here on the left, you can. I'm going to put the 3 here in the middle. So when I plug in 3 to my function, we're also going to use this to check our graph. So 3 minus 3 is 0. The absolute value of 0 is 0. Minus 5, so we're at negative 5. I'm going to use 2 and 4 because those are convenient points on either side. And so I should get the value 4 back, negative 4 back in both those cases. Okay, so let's just double check it. So f of 2 would be the absolute value of 2 minus 3. Okay, so that's negative 1. The absolute value of negative 1 is positive 1. And then we have 1 minus 5. So we do, in fact, get negative 4. If you plug in a 4, it'll work out. You'll get negative 4 as well. Okay, so I'm labeling the 3 points. And again, it's fine to label them here on the left-hand side in case your graph is getting a little bit too cluttered. And there's the graph done on Desmos. Okay, part B, same directions. This time we have f of x is equal to 1/2 x cubed minus 4. So our parent function is y is equal to x cubed. Okay, so that's this guy here. The 1/2 in front, that's going to is going to be a vertical change, and the 1/2 tells us is going to be a vertical compression. So remember, vertical changes are just what you think. So that 1/2 is kind of away from the x cubed. That's how I know it's going to be a vertical change. And vertical changes are just what you think. So since we're multiplying by a fraction, it's going to compress our graph. The minus 4 at the end moves the graph down 4. Okay, so I haven't shifted it to the right or left any, so 0 is still going to be a good number to plug in for x. So when I plug in 0, 0 to the 3rd power is 0, times 1/2 is 0, and then subtract 4, so I'm at 0, negative 4. Okay, now since I see that I'm going to be multiplying by 1/2, instead of picking 1 as my x value, because then I know I'm going to have to deal with fractions, let's just go with negative 2 and positive 2. Okay, so again, we can kind of do a little work here on the side to check our answer. So if I plug in negative 2, I'm going to have 1/2 times negative 2 to the 3rd power, so that's negative 8. And then I subtract 4. So half of negative 8 is negative 4, minus 4 is going to be -8. So I have -2, -8, and then when I plug in +2, I'm actually going to be up here at 0. Okay, so we could check that real quick. I'm just going to switch that -2 to a +2. Then this -8 would be a +8, and we end up with 4 minus 4, or 0. Okay, so those are the points. And just kind of sketch it in and make it look a bit like that, the squiggle that we had in our parent function. Okay, so let me go back real quick. Here on our parent function, if I plugged in 2, we would have been at 8, right? So think of that compared to the origin, we would have been 8 units up from the origin, okay? That origin, or that center point, was shifted down 4 units, okay? So I'm going up to get back to y is equal to 0. I actually went up 4 units, and I went down 4 units to get to -8. So instead of going 8 units up and down when I plug in 2 or -2, I'm only going 4 units up and down. Okay, so that helps hopefully explain that vertical compression. And there it is graphed on Desmos. Okay, now we have 3 times the square root of -x plus 1. So our parent function this time is the square root of x, which is this guy here just in the first quadrant. Okay, so let's see. We have that 3 out front, so that is going to be a vertical stretch. I have a negative in there, so that's going to be some sort of reflection, and then the +1 is with the x. Okay, so let's actually think about the domain of our function, and I think that might help us in terms of the reflection and then also how our graph is shifting. Okay, so this -x plus 1 is under the radical symbol, so it must be greater than or equal to 0. Subtract the 1 over, so I'd have -x is greater than or equal to -1. Divide both sides by the negative, and we'll have x is less than or equal to +1. Okay, so instead of starting at 0, 0, like our parent function does, the domain is kind of ending at 1. So I'm going to put a point right here. Okay, and I know if I make my t-table real quick, when I plug in 1, the opposite of 1 is -1, plus 1 is 0. Square root of 0 is 0. 0 times 3 is 0. Okay, and now my domain are numbers less than 1, so my graph is going to be off here to the left. Okay, and we'll plot some more points to get that curve looking a bit better. But it's going to be going to the left, so it's been reflected about the y-axis. Okay, and so if you remember, when the negative is with the x, like it is in this case, if the negative is with the x, that's always going to be a reflection about the y-axis. The way I remember it is that if the negative is outside, and I always go back to the parabola, if the negative is outside, that's going to make your parabola open down. So if a negative is outside, then that's a reflection about the x-axis. So if the negative is inside, it must be about the y-axis. Okay, and then we have that +1 with the x. Normally we would say, so it's a horizontal change, normally the opposite of what we might think, so +1 would really move your graph to the left one. Okay, I'm okay if you write that down. Notice that our graph actually moved to the right 1 unit, but that's because it depends on the order in which you shift the graph to right or left and then reflect it. Okay, so I'm more concerned that you know that it was shifted, it had a horizontal shift to it, and that your graph is accurate. So here I don't mind if you say to the right 1 unit, since the graph is now here at 1, 0, or if you say to the left 1 unit, knowing that it's like you moved your graph to the left, but then reflected that over the y-axis. And that's how we get the shape that we have. Okay, so let me erase this because we want this graph to be more accurate than that. Okay, and I'm going to go back to plotting points. And let's pick ones that are going to work out nicely. So we have 1, 0. Okay, so that's a key point that you have to have on your graph. 0 is going to be a nice, another nice x value to plug in. The opposite of 0 is 0, plus 1. So I'm taking the square root of 1, which is 1, and then multiplying it by 3. Okay, so I'm all the way up here at 3. That's that vertical stretch. Okay, and then let's see, we want another nice x value. Okay, so I'd like to take the square root of 4. Okay, so that means I want my negative x plus 1 to be 4. So we're going to go to negative 3. If I let my x equal negative 3, I would then have the opposite of negative 3, which is positive 3, plus 1 to get 4. Okay, so I'm kind of cheating a bit, working backwards, because I want the numbers to work out nicely. Okay, so plug in negative 3. Again, the opposite of negative 3 is positive 3, plus 1 to get 4. The square root of 4 is 2. 3 times 2 is 6. So then we have negative 3. 1, 2, 3, 4, 5, 6, all the way up at 6. Okay, good. And then we're going to sketch it. And notice we can really see that vertical stretch. So here's 6 and 3. Okay, good. And then it's always good to have labels on your axes. Okay, so I have 1 and negative 3 labeled, and then obviously 1, 3, and 6 labeled. Good. And there's a graph done on Desmos. I shifted over. We see here we have the negative 1, 0, 0, 3, negative 3, 6. Okay, and then it obviously keeps going to the left. Okay, the next one, part D, f of x is 1 divided by x minus 3 plus 5. Okay, so here the parent function is y equals 1 over x. Okay, so this one you might be less familiar with. This is called the reciprocal function. It's the one that's here in the first quadrant and then in the third quadrant. Okay, this guy, the parent function, the domain is everything except for 0. So we have this vertical asymptote at x is equal to 0. For our function, the one that we're drawing, that has been shifted. Okay, so this x minus 3 is going to move the graph to the right 3 units. Okay, also thinking about the domain, we know that we can't divide by 0, so x cannot be the number 3. Okay, so our vertical asymptote shifts along with the graph. I'm going to draw in the vertical asymptote here. Okay, so this blue line, this blue dashed line, those are x values that that we can't get to, right? So the function is going to go either up to infinity or down to negative infinity on either side of that vertical asymptote. Okay, so the graph moved to the right 3 units. Also, we have that plus 5 at the end. Plus 5, just what you think. We're going to move the graph up 5 units. Okay, I'm going to actually move the other asymptote along with it. So notice that our parent function has a horizontal asymptote at y equals 0. So that's going to move up to y equals 5, all the way up here. Okay, and then otherwise the graph looks the same. Okay, so we have part of it up, let's see, I'll use green. Part of it is going to be up here, and then the rest of it is going to be down there. Okay, so I'm going to do a better sketch, but I just wanted to show you, it's almost like these two asymptotes here. Maybe orange is better. These guys, it's like it's making a new center for me. So instead of the center being at the origin, it's up here at the intersection of those two asymptotes. Okay, so we still need to label 3 points on the graph. So we can't do 3, but 4 is a nice number to plug in. Okay, so if we plug in 4 for x, the denominator would be 4 minus 3, or 1. So we'd have 1 over 1, which is 1, plus 5, so we're at 6. We have the point 4, 6. That's right here. Okay, and then the graph is going to go towards those asymptotes from there. Okay, let's pick a point on the left-hand side. I'm going to erase this guy. Let's pick a point on the left-hand side of our asymptote. So 2 is going to be a good one. If we plug in 2, f of 2 is going to be 1 over 2 minus 3, so that's a negative 1. And then we add 5, So 1 over negative 1 is just negative 1 plus 5. So we'd be at 4. So I have the point 2, 4, 1, 2, 3, 4. Okay, and then from here, we know that the graph goes towards that asymptote and down towards this asymptote. Okay, I only have 2 points so far plotted, so I was asked to do at least 3. Okay, so let's pick another one. 1 is easy enough. Okay, so f of 1, we'd have 1 over, we'd get a negative 2 there in the denominator, and then we're adding 5, so we end up with 4.5, which is good. So that's what this value is right here. So we're just half a unit up from where we were, right? So here's 4, 4.5 is labeled, and I'll label my vertical asymptote. This is the line x is equal to 3, and it's also good to label the horizontal asymptote, which was the horizontal line y equals 5. Okay, and here it is on Desmos, and the scale's a bit better in this picture. Okay, and you can see that is basically the shape of what we had in the last graph.